The future energy source, solar power. What is solar power? Solar power is a renewable energy source that can be converted into usable energy. There are two ways to convert sunlight into electricity. 1. By photovoltaics, and 2. By concentrated solar power. The conversion of light into electricity at the atomic level is known as photovoltaics. Materials that exhibit photoelectric effect absorb photons of light and release free-moving electrons. By capturing and containing these free-moving electrons, electric current results. Thus electricity is formed. How do photovoltaics work? The diagram on the left shows a PV cell. Solar cells are made of semiconductor materials such as silicon. Silicon creates an electric field that is charged positively and negatively. When sunlight strikes the solar cell, electrons are knocked loose from the atoms in the silicon layer. With electrical conduction converted to the positive and negative sides, an electric circuit is formed, creating electricity. CSP technologies use focused sunlight. By using mirrors, sunlight concentrates and converts into heat. This heat is then used to create steam and channeled through a generator to turn a turbine. Electrical power is then generated. The trough system is another common way of concentrating solar energy. This system uses huge parabolic mirrors or reflectors. By tilting these mirrors towards the direction of the sun, light energy is focused on the pipes. Oil inside the pipes are then heated to 750 degrees Fahrenheit. Heated oil is then used to boil water into steam, turning turbines and generators. There are many applications of solar power. We will discuss 4 of them, mainly commercial, industrial, residential and medical. Some commercial uses of solar power include roadways, airfields, walkways and recreation. Solar energy has also been widely used for creating tourist attractions around the world. Since solar power is sustainable, it reduces operating costs. In the future, we would expect an increasing trend of organizations incorporating solar power into new architectural structures. Around the world, we can see many different commercial examples that utilize solar power. Diagrams on the left show some examples from Taiwan, USA, Seychelles, and Galapagos Islands respectively. For industrial uses, solar power is used at both photovoltaics and concentrating solar power plants. For concentrating solar power plants, they use thousands of parabolic mirrors to reflect the sun's rays to a tower-mounted heat receiver. High temperature then generates steam at the tower to drive an electric turbine generator. As for PV power plants, they involve stretching thousands of solar panels across hundreds of acres to convert sunlight into electricity for the electric grid. Other industrial uses include transportation signaling, such as lighthouses, aircraft warning light structures and environmental monitoring equipment. One novel way of using solar power is to utilize it for waste management. Powered by the sun, solar trash cans, also known as compactors, compress trash. This method allows more trash to be collected and lowers operating costs by 80%. By reducing fuel consumption, greenhouse gas emissions associated with garbage collection is minimized. Another novel way of using solar power is in solar deserts. Solar panels generate up to 10 megawatts of electricity a day, supplying electricity grids with power. This helps to provide electricity for up to 140,000 households in local desert communities. This scientific breakthrough is getting increasingly adapted by various deserts around the world. Do you know that deserts in the world receive more energy from the sun in only 6 hours than humankind uses in 1 year? Solar-powered deserts are also highly energy efficient. If we cover 4% of deserts in the world with solar panels, it will generate enough energy to power the world. One newly developed solar power technology is the super skin. Also known as ultra-sensitive electronic skin, super skin can be used to detect biological and chemical molecules to identify proteins in vapor and liquid environments. This medical breakthrough could prove useful for medical diagnostic purposes in the future. So how does super skin work? Super skin contains flexible sensors that are sensitive to pressure. Containing polymer solar cells, it generates electricity from solar energy. Super skin is made of a flexible organic transistor, which is made of polymers and carbon-based materials. By being able to sense touch, this layer of polymers changes thickness when pressed. As the thickness affects current flow, chemical or biological materials are detected, allowing for disease diagnosis. Super skin is also stretchable. It can stretch up to 130% of its original length and reduce back to its original shape without being spoiled. Having these sensors run on solar power reduces the inconvenience of using battery-powered sensors, which are connected to generators. This increases mobility and reduces the weight of medical devices. Advantages and disadvantages of solar energy. Here are some of the advantages. Firstly, solar energy is clean and renewable. Secondly, when solar panels are installed, solar energy can be produced for free. Next, solar energy will last forever, whereas it is estimated that the world's oil reserves will last for only 30 to 40 years more. Lastly, solar energy causes no pollution and very little maintenance is needed to keep solar cells running. There are no moving parts in solar cells, which makes it technically impossible to damage them. High return on investment is also expected from solar energy since a handsome amount of free energy is produced by solar panels. It is also estimated that the average household will use 50% of their energy coming in from solar panels in the future. Disadvantages include: 1. Solar panels can be expensive to install, resulting in a time lag of many years of savings on energy bills to match initial investments. 2. Electricity generation depends largely on the country's exposure to sunlight. 3. Solar power stations do not match the power output of similar-sized conventional power stations. They can also be very expensive to build. 4. Solar power is used to charge batteries so that solar-powered devices can be used at night. However, the batteries can often be large and heavy. Moreover, they also need to be replaced from time to time, which increases costs. The future of solar. Solar panel windows. Researchers from Michigan State University have created solar panels that resemble typical transparent glass. These panels can be attached with windows to collect solar energy. Scientifically, these panels are called transparent luminescent solar concentrators. They use organic molecules to absorb invisible wavelengths of light. By moving the wavelength of lights to the edges of the panel, where photovoltaic solar cells are, sunlight is then converted into electricity. When used on buildings, these windows are able to generate electricity to power offices and residential areas. Thank you for watching this video. For more information about solar-powered products, please feel free to browse through our website.